Let me introduce you to my Warco drill press. But could it be improved? Hi there, welcome back to the channel. So those of you who are new to the channel, I'll just give you a quick recap about what this whole project's about. So basically I'm taking my standard drill press, single phase drill press, single speed, and then giving it a host of new features. So one of those is to be able to control the speed variably using a 3-phase motor instead of the 1-phase we've got over there, and we've got an inverter and a control box to do that. Some of the other features are we're going to control the quill when it moves up and down, so have that running on linear rails so that runs up and down more precisely. And then finally we've got the table at the bottom, so I'm replacing the usual sort of drill press table with basically what you call an XY table off a knee mill. So nice things about that is you can move it up and down and left right in different directions and have its position pretty accurately controlled, and it'll stay in plane so you can do pretty precise holes. And then to top all that off, we're also going to have a go at adding some DROs, so we'll have a readout on that. So it should turn out to be quite a nice machine. The other feature it'll have is because of the 3-phase variable speed motor, I'm hoping to be able to tap holes, so I'll have like a jog function on the control system. So that is essentially what this video series is about. And the last video you saw me put together these plates, I'll machine these plates out and put those together. And once I'd done that and I took the last shot and edited the video, I had a look at this again in the workshop, and now it's in front of me, this big 1.1 kilowatt motor sitting up there in those 10mm plates just held in with the M6. Looked like maybe it was going to be a bit marginal. You know, would it catch if you had a 25mm drill in there and it caught on something? Would it kick it out of alignment because it's only held in with those M6s? And there was a comment made basically to the same effect. So yes, I agree with you. Now you see it, probably could do a little bit more of an upgrade. So my plan is to open these out to 8mm and then have a 20mm thick sort of side plate that comes in here, and then drills and taps into these side plates here, so sort of basically a big block that sits in here and blocks that in there, and the same the other side. Yes, as per the comment, I did think about dowel and pinning it. I think once that's in place it's not going to go anywhere, so that's what I think I'm going to end up going with. So we'll also have a look at machining these clamps. So these are the clamps that hold the box section side pieces onto the main column. So this is the 80mm column goes in here. So 2 of them are blank like this, and then one of them's got a hole curtain, holes tapped to take an FK12 bearing, which supports the ball screw. So that will be the unique one. But other than that, they're very similar. And then there'll be a strap clamp to finish that off and clamp it on around the tube. And we'll also have a look at these goodies that Banggood have sent to me to review. So we've got some 20mm rails and then the matching carriages. So these are a Machifit brand. And then in here we've got a 1605 ball screw and matching ball nut. And then finally in here we've got FK12 and the FF12 floating bearings to have a look at as well, and some of the accessories. Welcome to episode 7. Okay, so next up we're going to make 3 clamps. These clamps go between the main drill press body and the outer frame there, and there's 3 of them. One at the top, one a little bit lower down that holds the ball screw, and then one at the bottom. So as you can see, it's relatively straightforward. So we've got our 40mm radius part here that goes on the 80mm diameter tube, and there'll be this closing clamp that will be machined separately that will form the rest of it. Then we've just got a series of M8 tapped holes. So there's 2 that allow you to bolt in through the side frame into here, and then these front 2 will go on the main vertical plate on the front of the machine that holds the Z-axis linear rails. Then just to tidy it up a bit, we've just got these chamfers in the corner, just knock the edges off, make it a little bit nicer. So the piece we're going to use for that is this 5000 series material. I've checked it, it's very flat, so it's 20mm thick. There's enough in there to get 3 pieces out, because this is 600 long, and then there'll be a little bit spare, so I ordered a little bit extra just in case. This is a Rage 2 saw. It's got tungsten carbide blade on it. cut. It's designed for cutting steels and aluminium, although this 20mm plate is a little bit thick for it. So I find if you go really slowly, just come in and out, keep the blade cool. Also, if you can do it vertically on something this sort of size, it's better based on tooth engagement, how long it's in the cut, because otherwise you'll get aluminium clogged up between the gullets, and the thing will stop working. So it's just gently go through. It's certainly a lot quicker than bandsaw and an awful lot quicker than doing it by hand. So if you take your time, this works really well. Okay, so there's our 3 pieces. So they're 180 long, pretty square cut on the edges. That should leave us a little bit of stock. Let's go and set this up on the CNC machine. So for this setup, I'm using a very thin aluminium sheet as a sacrificial board, save me cutting through the main bed. Although it's not critical, I'm just getting the edge roughly aligned just to make sure I definitely don't run off the edge of the stock, because there's only a small perimeter left around the outside. And the last thing I'm setting up here is just some spacers. So I'll take these out when I actually machine the part, but it means when I drop the next blank in, I can put those spacer pieces in, they'll line against the reference parts, and it should get the next blank stock in about the right place. Right, so because the part's got no internal holes or anything I can clamp through, I'm going to use the open contour feature in Fusion 360. So basically what we'll do, we'll machine the front part here, and there will be 2 tabs that hold it onto this little waste piece of stock here. So we'll hold that on with 2 tabs, machine it round, rough cut it, then get rid of that and just do the 2 finish passes so we don't leave those little witness marks for the tabs behind, so we should get a nice finish. Then we'll move the clamps round to this side and then rough cut and finish cut at the rear, and that way we should get the perimeter machined nice and cleanly. Right, so we're all set up. Let's hit cycle start.
There you can see the tabs I used to hold that piece in place while I was machining, and then I decided I would manually remove those tabs. I didn't get it on film, but this is where the problem started. So when it cut free, the waste stock jammed into the main piece of work and knocked it out of alignment, so I lost all my data and references. I'd left 0.3mm stock to leave on the roughing cut, so there was enough to dial it back in, or so I thought anyway. So here we are, we clocked it back in, we're making our first cut on the finish pass. Unfortunately, as you can see, I've missed it. I've not clocked it in correctly and it's not cutting the part. So never mind, let's line it up, start again. Should be okay this time. Ooh, that was a bit heavy. Pause just to figure out what's going on. Thought, well, I've started now. Let's carry on. That looked like it was going okay, right up to this point. Ouch. Wasn't going well. So I thought, well, maybe I can recover it, maybe there's still enough left. I'll try the cam code out for the rear, so just make sure that G code works, just for cropping the rear piece off. And that didn't go so well either. I should have noticed it at this point, but it's actually cutting about 3mm off to the left, and that bit of chamfer is heavily cutting into the part. I'll zoom in a moment and just show you what's going on. See just there, it's taken the edge off. So we really have cut into the finished stock now.
Well, I've just made a piece of scrap, basically. So in the earlier op, I had this part held down here, and I roughed out the part using an open contour in Fusion 360, and that went well. But when I tried to machine these tabs away to get rid of this waste, I did that manually. When I was just on the last piece, this caught and flung it into the part, and I lost alignment. It pushed the part out of alignment. So I managed to dial it back in, clock it as well, I thought was correct. Then I did the finishing passes, and I've ended up with a step in it here. Well, okay, maybe I can get that back via machining it off somewhere else and bringing himself back on size. So I thought, well, while I'm here, I'll machine the back edge here just to finish it off, to get the rear edge correct. And I've obviously picked up my wiring correctly, and we're off by about 2 or 3mm at this side, so this feature's cut into the part. So, just made scrap. So let's have a closer look at these products that Banggood have sent to me. So regular viewers of the channel will know that Banggood send me things from time to time to include in the review and put in the project. I like to make sure I'm not here to just do a out and out review. I like to make sure the product that I talk about with the pluses and minuses is actually used as part of a project. You know, it's something I kind of need for the journey along the way. And I was looking for some linear rails and carriages, and they've just started stocking these 20mm variety of rails and carriages. Now you can see what by the colour scheme, the kind of brand that they're trying to sort of compete against. These are a Machifit brand, and they are considerably cheaper than some of the more named brands. So we'll have a look and, as best we can in the workshop, see what we think about those. In here we've got a 16mm, I think it's a 1605 ball screw, and we've got some matching hardware. So we've got some the ball screws. This is the floating FF12, and we've got the FK12. These are to hold the ball screw, so I'll have a closer look at those in a moment, and the matching hardware. So the first thing to say is how it came wrapped, because well, you've got to be careful. A lot of these products, when they're shipped and they're handled, they can get bent in transit, and if the rails or ball screws are particularly long, really you want them to arrive in some kind of wooden box. This one arrived in a cardboard box, but it is only 600mm long, and what you've got is a bit of a heavy wrap on the outside, cardboard, reasonably thickness, and then another cardboard box inside for the ball screw, which is the one that can get bent. The rest were tucked inside. You've got a little bit of this wrapping here, and it's kind of neatly all packed together. As far as I can tell, I have had a quick look, everything looks fairly straight, especially the ball screw, because that's often the one that I worry about. And getting bent, 'cause it's relatively soft and flexible. But so far, looks like everything's arrived in good condition. So let's have a look in detail about what we've got here. So let's start with these, they're the easiest ones to see. So these are the 20mm carriages. So these look pretty standard. You've got the grease nipple there as well. And you've got your reference datum on the side, reference datum on the side there. I've measured the whole pattern, it's exactly the same as the more branded version, exactly the same tapping, same fittings there. You've got the same kind of release, this plastic shroud here to hide the balls or retain the balls inside there. It's the usual recirculating ball system goes around, so looks pretty standard and so far feels quite well made on that basis. So we've actually got 6 of those. So there's 2 600mm 20mm rails that have arrived with the carriages already on, and then the 4 was supplemental that I added to that. So when you buy these rails, you get 1 carriage each, and then you add how many you want on top of that. You just pay per carriage to add to that. So that was that one. Let's look at the rails then while we're here. Now we've got to be careful because if this carriage comes off the end, all the little balls drop out, and you really don't want to be rebuilding these. So sometimes I put a cable tie through the last hole at each end just to safeguard that. What I'll do, I'll tuck it back in the wrapper in a moment. This is what you're getting close up. If you just have a look, that looks like it's been ground. Yes, if you look closely at that, it looks like it's been ground. This is not a reference surface, but at least it's had a level of grounding on there. What's more important is where the ball's running these little races here. So we'll try and do a kind of accuracy test in a moment, the best we can again in the workshop. The other things to note about these is I've held fire on machining the parts that these mates up to, because what I wanted to check was that they've got an equal distance from this end. So these are 60mm apart, 60mm centres, M5 cap heads I think they are that go in there. But you have to be careful because there's no guarantee that you're going to get sort of equal spacing. And on this one I think it's 28mm each side. Yeah, this as well. So basically the holes are kind of centralised in the rail. It's best to wait till the parts arrive to check that that's what you're going to get and not just some random offcut. I'm talking about rails in general, not just Banggood rails, but these are, I'm pleased to say, are centralised. And they come in standard lengths. I think, we'll have a look on the website here, but it goes in 100mm increments. But these are easy to cut down, so you can always order it oversize. And you just use a grinder with I think it's an inox a cut-off disc, normally 1 millimetre or so wide. Once you get through the hardened outer, it's fairly easy to get through. So you can crop them to length if that's what you need to do. Okay, so that's a quick look at the rails. So we've got 2 of those, 2 carriages, and then 4 extra carriages. And for the ball screw, we've got these 2 bearings. So I'll show you those in a minute. And the clip. So this is the bearing that goes at the top end, the driven end of the ball screw, and this is a fairly standard FK12. And again, I waited till this arrived before I finally drew the CAD for the parts that this goes into. But I measured it, and it's the standard size that you would expect. The bore, the length, these are M4 screws, the thickness. So all the dimensions match to the CAD. I think I downloaded the model off GrabCAD, so you just got to be careful when stuff arrives. Just make sure it does match the CAD. In this case, it matched the model I had in GrabCAD for this component, so that's good. So I'll have a look at that in a moment, but that's kind of giving your axial this way and your radial location for the ball screws, kind of holding it, allowing it to turn. So that's the fixed end. And then the other end is the floating end. The shaft just passes through. You can see it's just a regular 6000 series shielded. The Z is the metal shield bearing. So fairly standard there. And then the hardware you get is you get the little lock nut. I'll show you where that goes in a moment. It's nice to see they've machined that down, but occasionally you have to check that they have actually machined that true to the threads. I had some, they weren't Banggood items, but from other places where that wasn't the case, and that means when you screw them on, they don't provide the correct mating surface there, so you need to get them in the lathe and sort that out if you have a lathe. That's that, so we'll have a look at that, and then obviously there's the circlip that goes on the other end that allows that end to float. And then for the ball screw itself, that came wrapped in this extra cardboard box. So around it is to there. So I've already cut this open, it did arrive sealed. Everything's covered in grease, which is quite nice to see, it stops it going rusty. probably clean that off and put a grease that I know on there, but that's good for now. So this is the ball screw. So you've got this is the floating end here, so it's machined down. Focus here. Machined down, then there's the circlip groove, so that's that end. The ball nut, we'll come back to that in a minute. And then this end is the driven end. So we've got this part that goes in the bearing, the lock nut goes on there, and that will be for your pulley, your gear, whatever you're driving it with. And actually it was quite a nice feature that I noticed here. Often this is machined on ball screws that I've had in the past. Just trying to get that to focus. Oh, come on. Focus you. Yes, if you look at that there, that's quite nicely done. So ball screws I've had in the past, that's just been machined to quite a sharp edge, but they've put a sort of a radius on that last thread there that stops you catching your fingers and cutting them open on it. So it's quite nicely blended in to get that thread to start and still give you the face to mount the bearing up against. That's quite a nice little touch there. And then the ball nut itself all looks fairly standard, so I'm sure you know how these work, but just in case, there's a series of little ball bearings that run round these grooves in here, and they run around a circular track, they get fed through, then come back out again. A little bit like kind of Egyptians moving things on rollers. When the roller comes out the back, it gets fed in the front again, and you can move big things along, or in this case apply lots of force with very little friction. So essentially the screw is turned by the motor or whatever, and then the nut moves along, so turning rotary into linear motion. So all the fixings look fairly standard. You've got the regular seal on there, you've got this is where the recirculating balls go between these two orange pieces here, little grub screws to lock the seal in there. All standard. Feels pretty hard. Normally these are very hard, you have to cut them with an angle grinder if you want to do anything with them. So that's been hardened, and there should be a grease fitting somewhere, oil fitting, yep, there. So again, looks pretty standard. Looks like what you'd expect actually. And then in terms of running, hold it to the microphone. You can certainly hear the balls moving. It sounds like they're just starting to get bedded into the grease, and sounds quite nice. It won't spin freely because you're on these seals here, but it feels like it should. Yeah, it feels like everything's in order, and there is no free play in there. Now typically a ball screw like this, you've got 50 microns of backlash. Sorry, I don't know what that is in inches, but it's pretty small. So far so good, and I don't know if I can try and do it. I've tried to spin it. I'm trying to hold that still and just spin it. Not the best test in the world, but by eye I can't see any bend in that, so it's a ride and breaker condition. So yeah, so far so good. Okay, so this is the fixed bearing at the top end. This is our FK12 bearing, so that'll be held in a housing. And basically what happens is you've got a collar there that the shoulder of the ball screw sits up against, and then the other one is where the nut goes, and it holds it axially but allows it to rotate around like that while the thing rotates. And you have a collar in here. I'd expect that to be a 12mm ID collar, so we can just pop that out. There we are. It sits in this oil seal here. You can see the two bearings back to back in there. Okay, and in terms of the bearings inside here, I'll have to open it up to be sure, but they're probably just regular ball bearings or deep groove ball bearings. As far as I know, Banggood don't offer a more premium version of bearing, which will be the angular contact bearing, and that just gives you even more axial stiffness. I must say, for DIY use, and certainly for the project I've got in mind, the deep groove or just the regular ball bearing I've found to be okay. So let's have a look and see how it fits actually onto the ball screw. So it goes on at this top end here, and it will go like that. So the first thing is, how good a fit is it going to be over there? Okay, it slides on pretty easily. Yeah. Well, does it go on under gravity? Easily, yeah. Now, to be honest, that's going to be okay. So you lock up, put the lock nut on that thread, and it'll hold that pretty tight. I think that will be fine. In fact, you probably actually think about it, you put it the other way around, wouldn't you? But it's the same thing, yeah, same. Still, I think if I was machining that shaft, I'd give myself a new couple of hundredths of a millimetre. In fact, we can measure that and just see what it is. See how much it is under the 12. So I think functionally it's still going to be fine. We're going to still nip that up and hold that. Once we put that nut on, it's going to be okay. But maybe could have done with a couple of hundredths. But these are mass produced, so yeah, I guess better that than it having very tight and you have to tap it on, or even worse, you have to put this on a lathe, because not everyone would have a lathe necessarily. And then at the other end, so this is the so-called floating end. There we go. So we've just got a plain shaft there and a groove for a circlip, and that would go on. That's just your regular bearing, very simple bearing there, and that would go on to there. Actually, that's a slightly snugger fit. It's quite nice, that end. Sounds okay, looks straight. So yeah, I think that's going to be alright so far. Okay, one other thing that's worth pointing out, it wasn't clear in the picture or the description if I was going to get the lock nut and the circlip that goes on the end of the ball screw. So I think for $1.75 or something, I ordered a set. Well, I'll say $1.75. Obviously, I got all this for free, but I put that in the basket as well, and that's the order code there because I wasn't sure I was going to get them, but it turns out that you do get the nut and the circlip as well. So in terms of the carriages, this is what you get. This is the CA style, which is the style of the top here, which means this kind of square shape and with the tapped holes in it. You also get the grease nipple there, which goes in the end, whichever end you want to put it in. And then if we take it carefully out of the bag, it comes with the usual plastic clip at the bottom, and if I really carefully just push that back, you can see the balls inside, which give the, I can be careful if I don't want them to drop out. There we are, you can see them peeking through there in the return, and then maybe just see the row of them. Okay, there you go, there you can see them now. It's got a row of ball bearings at the top and a row at the bottom on that side, and the same on that side. So they recirculate around. So basically what happens is you offer this up to the rail, and then as you press it onto the rail, the plastic housing comes out the back, and then the ball bearings are captured and it's free to slide. And then to get it off, you need to do the same. You need to keep hold of this housing in case you need to take them off. So there we go. There is our Machifit HGH 20CA 20mm carriage. So far, looks okay. So that's what we've got. So we've got our two 20mm rails, 600mm long, with our two carriages on. We'll have another two of these carriages, 20mm carriages on there. And that's what the XY table, the kind of knee of the XY table, will move up and down on those four. And then there'll be two at the top, one here, and these will move the quill up and down. So that's our linear motion. And then to drive it, we've got the ball screw. This is a 1605 ball screw. That's our F grade 12 bearing, goes on there. And our nut, which goes on the thread there. Remember to put that face up against that spacer there. And it's got a little lock nut on there, or set screw, looks like an M3. You have to be careful, these very small ones, all the small ones really, they can round over. They can be annoying to get off again. That happens. Just nip that up for now. Feels okay. And then our floating end. Just drops on there. So there they are. So first impression's very good. Look like they're going to do the job. Let's see if we can take some measurements. Start with the ball screw. So this is a 1605 ball screw. That means 16mm diameter and 5mm pitch. So it's 5mm between each of these crests or troughs, however you want to think about it. And what that basically means then is that when we turn the screw one revolution, it moves 5mm. So if we turn it once, we get 5mm that way, or if we turn it the other way, 5mm the other way. Okay, and the thread itself is what's called a C7 grade, so this will be a rolled thread, and it's a pretty accurate thread, still pretty good, plenty good enough for any DIY machine, and I've used this grade for many years and been very happy with it. It is a lot more money, and I don't think Banggood sell this, but you can also get a C5 grade, and the thread has been ground in here, and it looks a lot different to this, and they are more accurate. But I think for most DIY machines, certainly what I've got in mind, this C7 grade, this rolled thread, will be absolutely fine. Another advantage of ball screws is because you've got the recirculating balls, there's very low friction between the balls and the ball nut and the thread, the ball screw itself. So it's very easy to turn even when there are high loads and you're lifting or moving a high load or moving a load rapidly. And the second thing is, because those balls move around and they're hardened balls and they move in these hardened channels, you get a long life out of it, especially if you put grease in them. So they last a long time, low friction, carry high loads. Unlike, say, a piece of all thread, although the principle's the same, you've got the inclined plane wrapped around a cylinder and you turn this and it moves the nut. But on this one, if you had a lot of load on there or you moved it rapidly, it would soon wear out and it would become a very sloppy fit on there, which is not what you want at all. Which leads me to the other advantage of these. This pitch on here is 5mm, which means when you turn it, it moves 5mm. It's very accurately machined, unlike, say, a piece of all thread, where I wouldn't like to guarantee what the accuracy would be like if you were using this as a linear motion system. Okay, now if we compare it to a piece of ball screw that I've already got, this is an offcut from an old ball screw a couple of years ago. It's very similar, but it's slightly different. So in there, that's quite close together if I compare it to what we've got down here. Before we do that, I'll just show you some of the things I've collected. So when you build CNC machines, you end up all sorts of bits and housings and old screws. Yeah, this is the bearing off a supported rail system. These couplings, which I don't like very much. I've had those break. I think they're okay for 3D printers, but for CNC machine, not really sure they're up to it long term. Yeah, I had to get a bigger one, but same issue really. I prefer the I think it's called an Oldham style coupler, where you've got two plus pieces and a rubber cross shape in the centre. A little bit more expensive, but yeah, if they snap on you, it's a real pain. Yeah, and all sorts of bits and pieces in here. Spare ball nut there. All the fittings for the greasing them, the caps. Oh yeah, that's worth. So a lot of the, like this. The ball nuts often, if you don't buy them when they're already on the ball screw or they're not been assembled, they often come with this kind of keeper inside there. Again, to stop the balls coming out. Here's another example. I think I might have even made this one. This is really useful if you want to get the ball nut off, because obviously as soon as you come off the end here, come off the end of that, all the balls will fall out. So you need to turn something so it will just fit on the end of there, because obviously not. Okay, that wasn't meant for this one. Such that this diameter is just right, so the balls can carry on, and then you can feed it onto here. Or if it arrives and you need to turn this round, because sometimes these are the wrong way round, so you need to make yourself a little tube, or hopefully it's not been installed, and then you can put it the right way around with this little keeper in here, and then you sort of feed it on. So that was that. I thought you might be interested in that stuff. You build up quite a collection over the years. Okay. Bringing it a bit closer, this is an offcut from a ball screw I've had for many years. It's off an old machine. You can see it's similar but not quite the same. So you can see that black line there. Looks slightly wider on this one supplied by Banggood. So possibly come from different factories. This one is unbranded. I mean, it's supplied by Banggood, but it's not branded as Machifit or anything like that. And so this is the one they've sent me. But otherwise, looks quite similar. I guess the critical thing really is these grooves in here, because that's where the balls run. And they're both rolled, obviously, and it looks quite similar. Okay, now all the ball screws I've ever bought, I've bought quite a few now, they've all from different suppliers, and they've always arrived slightly bent, even if they come in a wooden box. It seems that when they're rolled, that's what they do, and they don't necessarily straighten them. Now one of them was quite bad, it was quite a long one of them was quite badly bent, and you can tolerate a little bit of bend because there is some flexibility in this, and when this is held and this is held and this is held and whatever your carriage is that's moving backwards and forwards, it will sort of straighten it out within reason, and you can tolerate a little bit of run out in the ball screw. But one I had years ago arrived and it was just out by too much, and it was actually making this quite noisy, and I thought this is not really going to last very long. So I sent it along to this company. I had to wait for them to be doing straightening at that point, so I think I had to wait a couple of weeks while they did a batch. You know, I'm only a one-off, so I just had to sort of go on the back of whatever they were doing at the time. I think it was about £40 to have this ball screw straightened, but it came back really straight. It was really nice. So if that's critical to you, wherever you're buying your ball screws from, I don't think Banggood's any different. We'll try it in a minute. We'll measure the how much the run out we've got in it and how bent it is. You might need to factor that in if you want to make your ball screws run really, really straight. So with that in mind, let's just see how straight these ones are. So we'll try and set it up with some kind of fixture, and we'll try and measure it as best we can. Okay, so we've got it set up now on these V blocks on this flat surface, and what we're going to do is just try and rotate it. You can just see it's just resting in there like that. Rotate it, and then we'll just have an indicator, and it will just sweep along this surface here. Just in case you're wondering, I think some of you saw this in my CNC build video, this plate, and I've got another one like it as well. This is not a surface plate, it's not calibrated, it's not certified to be any particular flatness, but it's the flattest thing we've got in the workshop. And if I put a known ground flat edge across it and shine a light underneath it, I can't see any daylight in it. And I guess the other nice test is if you have a ground block like this is a cast iron ground block, and then you put it on the surface like that. You might not be able to see on the camera, but if I now lift that up, it's kind of got a suction effect to it. I can't lift it, and then suddenly, yeah, oh, you might even see it almost sort of floating on there. I lift it up, oh, and then suddenly it goes. So it's reasonably flat. It's the best thing I've got. Let's see what we can set up here. All right, I'll bring you in a bit closer. Okay, so we've got an indicator that's going to sweep along here when we turn it, and we'll just have a look and see what the reading is. And again, this is not the world's best setup, but it's a setup. As you can see there, the indicator's held on that large cast iron block there with a mag base. Well, this could be a little bit more rigid, but let's just have a look and see what we get. So I'll try and keep that in view. There we go. And then we'll just rotate the ball screw. So each division on there is 0.01 millimeters, a hundredth of a millimeter. Probably moving about 0.06. Let's go back the other way, run out. Let's try and zero it. Where's the high? There. Okay. Oh, the other way. Right. Okay, let's try it. We'll go this way now. 1, 2, 3, 4, maybe 6, and then back the other way. Now, of course, we could be measuring a couple of things, a few compound effects here, like maybe waviness of this surface, but this will have been turned, and there's no way it's going to be that. And this is actually pretty good. I've had a lot worse than this. So 0.06. I've run out in the centre. It's reasonably consistent. I've run out of travel. I'm pretty pleased with that. Right, we'll just try it at this far end up here. Okay, now we're at the driven end of the ball screw, so we'll repeat that and just see what we get. That's about 0.05, yeah, pretty similar. Okay, now just to check it's not the waviness of this surface. I don't think it will be. We can just try, see if we can get it on the other side. Now we're only going to be able to go so far because there's one of these orange caps in the way there, so let's try that way. Here's 0. Yeah, it's doing a similar thing that side. Okay, we're now at the floating end, so we'll just try that again. 1, 2, 3, 4, 5, 6. Oh, there's 0.1, it's gone more. 0.11, 1, 2. And back again. I think that'll be fine to go on the machine as it is. So, yep, pleased with that. Okay, so we're 0 degrees level on the handle and we're at 0 on the indicator. So let's turn it and see what we get. That's 1 millimeter, 2, 3, 4, 5. Put the chronometer on. So we'll keep going until this reads 0 and then read off the dial over there. That's 18, 17, 16, 15, 12, 9, 7, 6, 5, 4, 3, 2, 1, half, 0.2, 0.1, 0. And we got within a fraction, 0 here. So I'd call that, yeah, 5mm pitch. Okay, I've got this set up here. I was attempting to measure the backlash on it. I've basically put a load on the ball nut, fairly heavy load on there, just to make sure that when I change the direction, I was hoping to overcome the friction in the seals so I'd get the genuine free play of this. But the reality is that just the merest fraction of a movement on here, the needle moves straight away. I'm just trying to pick it up on the inclinometer. I've just got not enough resolution to pick anything up. I suspect this load is not really high enough to sort of bring that out. So we can't really demonstrate it here, but typically they are 50 microns or less. Okay, but if you look across to here on the CNC machine, if we look at the ball screw on the x-axis, we've currently got 2 on there, but before I put 2 on, I just had the 1, and I did some tests to understand what the backlash was. So when we only had the 1 ball nut on there, I was able to move the axis this way using the controller in really, really tiny steps, and then reverse the direction and put very, very tiny steps into the stepper motor. And I had a DTI on here and I measured how many little steps it took until it started to come back the other way. And the answer I think was around 40 microns on this one, which, you know, for most machines would be absolutely fine. So that's a very small number. What I chose to do on my design here though was just double it up and add another ball nut at the back here, and one of these, I think was this one, was in a slotted hole, so I was able to lightly clamp these together and then do the screws up on here, so there was a permanent amount preload. Now there's no springiness in that preload, it's just a set amount, so of course if there's any slight change in the pitch along here, which there will be, this preload may vary slightly, but in practice I've found it's very low backlash when you do that, so you can get even lower, but the standard ball nuts are typically up to 50 microns. Okay, well, let's put all this stuff away and we'll have a look at the linear rails. Okay, so this is our 20mm rail. Let's have a closer look at this and see how it performs. So when we talk about linear rails, the main thing you want from your linear rails is straightness. You know, that's the basic reason why you're buying the linear rails. You want them to be nice and straight so you can produce accurate work. Well, I guess straightness and maybe hardness as well. So you want some durability as well. So yeah, two main things that you want is straightness and hardness. Actually thinking about it, you also want efficiency as well. So you want a nice smooth motion. You want to be able to drive heavy loads quite quickly, rapid acceleration without having massive motors. So yeah, I guess there's three things, aren't there? Straightness, hardness and efficiency. Oh, and you probably also want durability. You want it to last a long time, so you need some durability. So I guess there's four things really. Straightness, you want it to run in a nice straight line. Hardness, you want a nice hard surface for it to run along. Efficiency, you want it to be nice and easy to move along, so you're not putting too much strain in the whole drivetrain. And you want durability, you want it to last a long time. You don't want to have to maintain or change these out, sort them out regularly. Okay, so what we've got here is the carriage clamped very lightly in the vise. What I don't want to do is, because it's kind of C-shaped, I don't want to squeeze it in or make any changes like that. So it's just clamped enough so it doesn't tip, which means we won't be able to run the full extent because just the weight of it hanging off here will tip it out the vise. So we can run most of this section, and what we're just going to do is then check the relative difference between, so we're on parallels on this surface at the bottom, and we're going to check what happens against the rail here with our DTI as we slide it through. Okay, here we go. Pretty good. Okay, it looked like it was dragging slightly and making the needle move a little bit. Plus this is probably not particularly stiff. Don't know, maybe we need a more accurate setup. It's obviously pretty low. Let's try with the other indicator. Okay, let's try again. Okay, so within the limitations of what I can measure with this setup, because it's not infinitely rigid, it looks pretty flat, at least in this sense, or pretty parallel at least in this sense. Okay, so now we've got the indicator running in one of the grooves, so the little balls run in this groove at the bottom, and then this groove at the top. And that was the easiest one to get into and indicate off, so we'll run it backwards and forwards and just see what happens in this sense. Obviously within the limitations of what we've got set up here. Okay, so here we go. Okay, within the limitations of what we're actually doing here, we're only picking up a single point. It does still suggest it's running relatively parallel. I guess you really need multiple points and a more complicated setup to be sure, but I think for what I'm doing on the drill press so far, this looks more than good enough. Okay, so there's our 20mm linear rail. Okay, let's sum up then. So in terms of the ball screw, we measured the run out. I think it was about 0.05, 0.06 and maybe up to 0.1 this end. I've certainly had an awful lot worse than that. Every ball screw I've ever bought has been bent to some degree, so these are no different. We couldn't measure the backlash. I couldn't really get that to work on this setup, but they look an awful lot like the ball screws I've bought in the past, and they're up. I've measured those up to 50 microns, so don't know on that one. We'll just have to go with the specifications. And then in terms of the bearings at each end, that was a reasonable fit on there. Maybe could have done with being another 100th larger, but we're still going to work. The nut went on nice and square, so that was all fine. This was actually quite a nice fit this end. I did measure it and it's a very slightly better fit on here. This is 10mm nominal at this end. and there's a circlip, so that end looks okay, spun freely. Okay, and then moving on to the linear rail then. In terms of the spacing, the whole pattern there, that's a standard spacing, so that's nice to see. Standard spacing between here, 60mm. They've centralised the hole, so you've got an equal offset on each side, so that's nice to see. Within the limitations of the test that we just done, they're running really reasonably straight and parallel. We measured in the 2-axis. I know it's not an exhaustive test, but it seems to suggest that they're running relatively straight. In terms of their intended application on my drill press upgrade, these are going to be more than good enough. Are they good enough for a CNC machine? So far I'm not seeing any negatives. The only thing that I can't really testify to is how long they're going to last, because clearly I haven't really built the machine yet. So if any of you got any experience of these are Machifit brand, so everything you see here from a linear rails point of view is made by Machifit. The ball screw and the accessories are unbranded. They look generic, possibly made in just 1 or 2 factories and then distributed through all the different retailers. If anyone's got any experience of using the Machifit brand or the Banggood ball screws, just let me know in the comments below. What I'll plan to do is, when the machine is finally finished, which could be some time away, I'll run with it for a little while, and if I find any issues or have any problems with it, or these turn out not to be durable or whatever, maybe 6 months after I've built it, I'll come back to this video and I'll put some comments in the text box. Okay, let's have another go at machining these parts out. So I've put my stops back in. Let's give my stop that side, stop there, and another one there. That's my waste board there. And then here's the piece. So they were cut to about the same size. So what I'm hoping is, if I put them up against these stops here, it will be in pretty much the same position as before. So it should just be a matter of pressing cycle start and off we go. So let's get that clamp down. So just take our stops out. Okay, we should be in about the right place now. So this time I've changed the cam, so we're basically still going to machine down the side and around here, around this side, and then come back and repeat, so it's an open contour. The only difference is I'm not going to leave those 2 tabs on there, so I'll cut all the way through. So it'll be held in place with this one right until it makes that final cut through, and then just at the end there it will break free, but it'll be held in at the rear too, and it's basically only going to take a tiny bit out here, so I think it will be fine. Let's get going. So in terms of the clamps, we've got one of them made up here. It's all deburred, it's got the right shape. Obviously we've yet to put all the holes in all around these sides. That's one done. I've got a second one done here. It's similar, except now we've got these holes that will take our bearings, our FK12 bearings, holds the ball screw. So that drops into there, hopefully. I haven't tried it yet. Oh, there you go, that's good. And there we go. Lines up on all those holes, those M4 tapped holes. That'll hold that rigidly. That's nice. And then we got the one that didn't go so well. So we're running around the profile, and I think it was here. You can just see that witness mark where it kicked out. Kicked this piece of stock here, moved it out of alignment. I tried to dial it back in. Something didn't go well. Also got that step. Thought I could recover it, so I machined the back. So I still had stock to leave. Machined the back edge, but then finally, obviously something's wrong there, and it took that chunk out. So I've got some more material on order. So when that comes through, I'll machine another one. It's basically the same as that. It goes. So there's 3 of them. Top one will be there. That's the next one down. Then this will be the lower one. So I've got those material on order. I've also got material on order for the clamp, so there's a closing piece that goes on all these 3, and we've also got some material on order to do the next round of machining. So my original plan was to also get this mounted up onto the drill press, onto the column, remove the table and get this mounted up, but as I mentioned at the beginning of the video, I want to make these blocks that go in here that give this some rigidity and stop this moving, so that's going to be easier to do while it's down here on the workbench rather than trying to do it when I'm balanced up there. So we've got that stock coming in as well, and while I was there I ordered up the next set of parts, or next set of blank material, to be able to machine some of the next pieces. Okay, so that's it for this episode. Hopefully you enjoyed it. Hopefully you enjoyed the review of these Machifit rails and these generic ball screws and accessories. Hopefully you enjoyed the machining as well, so we've made some good progress there. Had a few incidents along the way, but that's what happens when you embark on these projects. We've got a lot more material on order, so we can do some of the next steps. Yeah, hope to see you in the next one. Till then.